Good morning, students. Today we'll see about what is air conditioner and refrigerator, how it works, what is the principle behind it. First, we'll see about what is air conditioning. Air conditioning is a process of treating the air in the internal environment so that we can establish, maintain the required temperature, humidity, cleanliness, and motion. So first we'll see about what is temperature. The air temperature is controlled by either by heating process or by cooling the air. So cooling is technically means the removal of heat. So in contrast to heating, the addition of heat. The humidity is nothing but the water vapor content of the air is controlled by or by removing the water vapor from the air. So if I'm going to add the if I, if I control by adding process means that is called humidifications. Or if I'm going to remove the water vapor, that process is called as dehumidification. So adding is humidification and removing means dehumidification. This is the process we do in the humidity. Cleanliness is nothing but we are going to improvise the air quality by either filtration process, that means the removal of undesirable contaminants using the filter, or other devices, or by ventilation. The introduction of outside air into the space which dilutes the concentration of the contamination, and often both filtration and ventilation are used in the installation process. What is meant by motion? Air motion refers to the air velocity and to where the air is distributed. It can be controlled by appropriate air distributing equipment. Next is going to be your sound control. How? So in this regard, we are going to see one important function called auxiliary function of an air conditioning system, even though the system itself may cause a problem. The air conditioning equipment may produce an excessive noise due, which requiring an additional sound attenuation. That by attenuation is nothing but removal of noises as a part of the equipment. So next we'll see about what are the components of air conditioning system. We know that heat always travel from a warmer to a cooler area. So definitely we know that air conditioning becomes a more effective only in the summer. But in winter, if you see that there is a continual heat loss from within the building to the outdoors. If the air in the building is to be maintained at a comfortable temperature, the heat must be continually supplied to the air in the rooms. The equipment that furnishes the heat required is called as heating system. So in summer, we know that the heat continually enters the building from the outside towards inside. In order to maintain the room air at a comfortable temperature, this excess heat must be continually removed from the room. The equipment that removes the excess heat from the room is called as a cooling system. So in winter, it works as a heating system. In summer, excessive heat is removed from the room. That is called cooling system. This is how the process of air conditioning gets works. So what is an air conditioning system? It may provide a heating, cooling, or both. We can do it. The entire thing depends on the size and the complexity may ranges vary from what single space heater or window unit for a small room to a huge system for a building complex. So the size of the air conditioner depends on the space, the area, and where we are going to do it. Depending upon that, the what AC, the air conditioning system equipment design is going to vary. The most of the heating and the cooling system must have the following equipments. That is called as a basic equipments. One is a heating, next one is cooling source, third one is going to be a distribution, fourth is going to be the equipment, and what are the devices we are going to do it. First, we'll see about what is a heating source that adds the heat to the fluid. Fluid is nothing but my air, water, or steam. Next, a cooling source that removes the heat from the fluid. Heat from the fluid. That is called air, for example, air or water. A distribution system is nothing but it is a network of ducts, or else we call it as a piping, which is able to carry the fluid to the rooms to be heated or to be cooled. Next is going to be your equipment. Equipment is nothing but the fan and the pump, what we say it. It is mainly used for moving the air or water. What are the devices? That is nothing but example radiations. Radiations or the device which is used for radiation for transferring the heat between the fluid and the room. Next, we'll see about what is all water air conditioning system. So the figure has been shown here. This is a typical hydraulic heating system. We can call it as all water. It has shown in the figure. There are different parts we have shown here. There are four parts mainly we are going to show here. The first one is a hot water boiler. You can see in the left side there is a hot water boiler is there. The heated water is circulated by the pump. You can see the second component is pump. The heated water will move to the pump and then it travels to the room through the piping. We are using a piping. Through the piping, the water, the heated water will be going through the pipe and they enters into the terminal unit. That is a big unit we have it. So the room air is heated by bringing into the contact with the terminal unit. So we are going to bring the room air in contact with the terminal unit so that the water loses some of its heat up to the rooms. So it must return to the heat source to be reheated. This process goes on until we find a sufficient cooling has been provided in the room. So next we'll see that hydronic heating and cooling system. This is the figure we have shown here. This is the hydronic heating system. We call it as a HVAC system that require both heating and cooling. This is because it is possible to use same piping system for both by connecting hot water boiler and water chiller in parallel. So in the previous case, only hot water boiler is there. Here, both the system we are using it. One is a heating source, another one is going to be a cooling source. So this it has been used when it is required. So this is the further process how it happens here. We are going to say here how the working process is going to be handled in this air conditioning system, all air conditioning system. So the air in all air system uses the air to heat or cooling the system. So here they use the air to heat or cool the rooms. They may also be added capability of controlling the humidity and furnishing the outdoor ventilation, which is the hydronic system cannot do it. Hydronic system cannot do it, whereas the all air conditioning system can able to perform this process. A typical air heating or any cooling system, which has been shown here, where the air is heated at the heat source, such as a furnace. You can see that we have a furnace. Next, it may be also you be using an coil circulating the hot air or steam heated by the boiler. Whatever the boiler contains the water, that may be circulated as a hot water or in the form of steam. So the heated air is circulated by the fan tube. So you can see that there is a fan tube is available. That fan tube will circulate the heated the steam. So, and it travels to each room through the supply as an water. We call it as an air duct. Through the air duct, it has been supplied to the room. The supplied air enters into the room through the outlets called the air diffuser. We can see that in the room there is an air diffuser. Through that air diffuser only, the air will be supplied to it. Or we can call it as a register 4, right? That are been designed to provide a proper air distribution in the room. So when the warmed supply air enters the room gets heated. So what will happen? So warm water is getting into the room and the room gets heated. The humidifier which is available which has been shown in the figure may also be included to maintain the comfortable room humidity in winter. So they're providing a comfortable humidity they are maintaining in the room. So during the winter season, the arrangement of basic components for any all air heating system or cooling system has been shown how the structure has been processed. So in the case of summer, if you come to the summer season, where air is cooled, when it flows over the cooling surface, which is mentioned as a pipe, usually as a coil of tubing containing a fluid cooled by the refrigeration equipments. So the water gets cooled by the refrigeration equipments. Then we are going to send it to the pipeline. Then it is enters into the air ducts and it has been supplied to the room. When the cooled supply water air enters a room, the rooms get cooled. So this is the during summer season how the all air conditioning system gets worked. Because of the room size is fixed, the same volume of the air that enters the room must also be exist. So whatever the air is in, it also get exist. So this is usually accomplished by we call it as air ducts. So through air ducts only the process will move in and around, right? The air is then heated or cooled again and it is been recirculated. This process goes with a cycle. So an outdoor unit will be there that where the air induct, which has been shown as a number 7, may be provided for introducing fresh outdoor air for increased air quality. If you want to increase the air quality, the outdoor air intake duct we will be provided for introducing the fresh outdoor air, right? So similarly, the same volume of the air must be exhausted through the we have shown in the number 8. Through that way, it get exhausted. The provision may be made for cleaning the air with the help of an air filters. It has been shown in the number 9. What is called an air filters, and for humidifying the air, it has there is an outlet. There is a outlet is there. We call it as a 10. That is for going for humidifying process. So next we'll go for remote control buttons. What is the use of remote control buttons? We know that in our home we are using and remotes for controlling the what temperatures. So if I vary the temperature according to that, my cooling level gets varied. So the outdoor unit must have the other parts of the system like compressor, air cooled condenser, condenser fan, and its own motor, and it has installed which has been installed outside the room, right? So the liquid or the suction lines of the system have to be laid at the site after the outdoor and indoor units are installed in a particular position. So the distance between the outdoor and the indoor unit has to be as small as possible. If this distance is more, we can't. So it takes a longer time to go for the process. As the distance increases, this pressure drops in the suction and the liquid lines also increases, resulting in reduction in the unit capacity. This is the process. So since the compressor, which is lies outside the unit, is remotely installed from the room to the air condition, the noise level will be appreciably, we can make it as less in the case of room air conditioner. So this is the advantage and the reason for opting for the split ACs. Both the room and the split air conditioners and the typical remote control are being shown in the will have in the next slide will show how it is work. I mean remote control buttons are there, right? Combination systems. Combination systems are nothing but it is frequently desirable to combine the water and the air system. So combination system is we are going to combine water and the air systems. For example, there may be a instance where the certain part of the building may need a cooling while the others require a heating simultaneously for providing a comfort condition in all areas. So a typical application of this type of air conditioning system may be used in big big systems. So, what we can, for example, in hotels, in in big industries and all, we will be using it. The heat removed from the areas requiring a cooling is transferred to the areas which requires a heating. Such a system is called as heat recovery system. They are distinguished only in the case of heat pump. So this is called unitary and central air conditioning system. This is like a Windows AC. The unitary or the package of air conditioning systems uses the equipment where the most or all of the basic components have been assembled in the factory. So it most probably it is being used in the factories. So it has been used as a room conditioner, room air conditioner. The central or the built-up air conditioning system uses the equipment centrally, which is located in the mechanical rooms. So each piece of the equipment is installed separately and they are connected to the job rather than manufactured as a spare package. You can see that where the system is. We have an air inlet, we can have an air outlet. We can see that how it is the windows have been shown here, and you can see that each and every equipment what will happens in the inner, how the air flows inside the blades, and outdoor flow blades have been shown here. This is the outdoor blades. This is the air inlet where it goes air. This is the air which comes out of it. That is called air outlet. And this is called the ventilations. So split air conditioner, that is a window type. This is a split air conditioner. So nowadays we are using the split air conditioners in every houses, right? In split air units, the outdoor and indoor section of the room air conditioners are separated into two casings or units. The indoor unit is consists of evaporator coil, evaporator blower with its own separate motor, or through a capillary tube, and control panel which controls the flow of air, and also we have an air filter, and we can have a return grills, etc. These are the equipments we have in the indoor unit. It has been installed inside the room, whereas it can be ceiling suspended or wall mounted, or it can be kept on the floor as a console unit, and is generally known as an fan coil unit. So this is about the air conditions, how it works, and how it does what air circulation takes place, how the both how it works in the winter season and outer season we have told. Now we'll come to the refrigeration part. Refrigeration is a process, an environmental control system that includes the cooling and dehumidification, will require a mean of removing the heat from the condition basis. Because of this heat flow from the higher to the lower temperature, the fluid within the temperature lower than the room design temperature must be made available, to which excess room heat can be transferred. So what it excess heat can be transferred from the room, there is a what we call it as the heat flows from the higher to the lower temperature. So this is a process we are going to do with how it reduces the heat. A natural heat sink that is occasionally used for cooling the water in the atmospheric air. In climates where the humidity is extremely low, evaporative cooling of an air may be reduced both the air and the water temperature, which is low enough so that either it can be used for cooling. So what they say is that in evaporative cooling of an air, which may reduces the air and the water temperature, so that it can be sufficiently used for cooling the system. So what actually the refrigeration system is? It extracts the heat from the substance at a temperature which is lower than the ambient value. The transfer of the heat transfers the extracted heat to the atmosphere at a temperature higher than the ambient temperature. So they extract the heat which is above the ambient temperatures. That is the process we do it in the refrigerator process. So the heat recovery systems, when its refrigeration effect is utilized for cooling any area or the fluid, and the heat rejection is a put to the sum of the beneficial uses. What they say is that there is a heat recovery system is used, so that it is utilized for only for cooling the particular area. So there is a heat pump is there. The heat why we use a heat pump means when it is used for any cooling process during a summer and heating in winter, by incorporating a suitable what changeover we are going to give it from the cooling to a heating modes and vice versa. There is a heat pump. So it varies. It maintains the heat the temperatures depending on the environmental study, whether if you in the winter it makes the heat process, in the summer it provides a more cooling. So for if I want to go for any food preservation, both for a processing or any storage, so one of the significant application, this is one of the most significant application of a refrigeration, most probably we go for food preservation. So if I want to maintain the food for preserving means, so I have to maintain a proper cooling or a proper a temperature I has to maintain. So for chilling, freezing, quick freezing or freezing, drying, everything. So the typical applications of the mainly utilized domestic refrigerators and home freezers. So ice cream manufacturing and storage, drinking water coolers, beverage cooling, cold storage, process of cooling of meat, fish, dairy products, vegetables, fruits, and transport of refrigeration, everything we can. These are the some of the food processing will do it. So the refrigeration is most important, or we can say it's a more vital to the chilled and frozen fruits industry for maintaining the cold chain, that is supplying such foods from the farm to the consumer. So the transport refrigeration is an important link in this chain. So the condition of temperature and the relative humidity are dictated by the application where the refrigeration system is intended. So now what are the refrigerants I can use for it? So the refrigerants are the heat carrying medium which during their cycle in the refrigeration system they absorb the heat at a lower temperature level and discard that heat to and discard the same amount of heat which is absorbed to a higher at a higher level. So they suck the lower temperature level and discard that heat into a higher temperature level. These refrigerants have been used from 1930s because they are excellent characteristics. They have a good physical properties for performance, temperature, pressure, oil mixing feature mixes and heat transfer specific, etc. They are very non-toxic, stable and inexpensive. So what are the refrigerants we can use it? We call it as CFS. So it is going to be a chlorofluorocarbons which is composed of chlorine, fluorine and carbon atoms. Since this group are called as R1, R12, R11, R12, R1114. Hydrochlorofluorocarbons are composed of hydrogen, chlorine, fluorine, and carbon atoms. Some of these groups are R122, R123. There are also composed of hydrogen, fluorine, and carbon atoms. Some of these are R13, R134A, and R125. These are some of the refrigerants we go for using for your cooling system. So now we'll see the schematic diagram of how the refrigeration system will be. So the basic components are vapor evaporation, or we can call it as a vapor compression refrigeration systems. So this mainly used for understanding how the some of the typical temperature of air conditioning applications are also been indicated. And also we are going to see about the refrigerant fluid circulates through the piping and equipment in the direction we shown in the we are going to show in the further coming diagrams. There are four physical processes we'll do it, that is which changes the condition of the fluid and that occurs as it flows through the system. So there are many process we are going to do it. First process is the process 1 to 2. What is that process we are going to call it as? At the point 1 in the successive next slide will show how this process they mentioned 1 2 and all this 1 2 has been shown in the next slide. At the point 1 the refrigerant is in the liquid state. So at the point 1 the refrigerant will be in the liquid state which is at relatively high pressure and high temperature is maintained. It flows to the point 2 through which we call it as a flow control device or expansion device. The refrigerant loses its pressure as it goes towards a point 2. Next, when you calculate the pressure at 2 is low at that a small portion of the refrigerant flashes or we can call it as evaporates into in the form of gas. So, but in order to evaporize, it must gain a heat which it takes from the portion of the refrigerant and that did not evaporate. Thus, the cooling mixture and the resulting in a low temperature at 2. So, what this says that so when it enters into the point 2, it is very slow. It is in a small portion of refrigerant. They get evaporated. They get evaporated in the form of gas. In order to make since we are doing an evaporation process, it must gain a heat so that it takes the portion of the refrigerant which does not evaporate. So they are dividing the refrigerant which does not vaporize it, and thus they are going to do the evaporized refrigerant which is in the form of gas. Both can be combined together, or we are going to form in the mixture, and we are going to and the resulting mixture will be maintained at the low temperature. This process will be taking place on the point 2, that process 2. So from the process 2 to process 3, the refrigerant flows through the heat exchanger, which is called as an evaporator, which exchanges the heat exchanger has two circuits. The refrigerant circulates in one and in other, so that the fluid can be cooled. That is, we usually say it is in the form of air or water, which can flows into the point 3. The fluid to be cooled is the fluid which is to be cooled will be maintained at a high temperature than the refrigerant. Therefore, the heat is transferred from it to the refrigerant producing a cooling effect what we decided. So what they say is the fluid to be cooled, we are going to maintain at a high temperature, which is normally higher than the refrigerant temperature. Therefore, what will happen? The heat gets transferred from the cooling to the refrigerant ambient temperatures. So what they say that the producing cooling effect is so that we can get the proper cooling effect. The refrigerant boils because of the heat it receives in the evaporizer. By the time it leaves the evaporator for and it is completely vaporized. So this is the process. We have shown that I've told that there is a unit is there. I have mentioned what will happen, how it enters, and how it get processed. Now, when you go to the process, what will happen when it leaves from process 3 to 4? So what they say is that we told that it is getting completely evaporated at the point 3. So the leaving the evaporator, the refrigerator or the refrigerant will be in the form of gas at a low temperature and it has a very low pressure. In order to able to use it again to achieve the refrigerating effect continuously, it must brought back to the conditions at one, which is in the form of a liquid at a high pressure. So in order to make it as a proper circulation, again the cycle goes on from 4 to 1. 4 to 1 means initially what we have kept it, it is in the form of liquid. The refrigerant will be in the form of liquid. It is maintained at a high pressure. The first step is the process is to increase the pressure of the refrigerant gas by using an compressors. All these things will be happening in the compressor. What the compressor will do, it compresses the gas. Also, it results in an increase in temperature. So, what will happen to 4 to 1? So, this is happens again. I told that it goes back to process 1. The refrigerant leaves the compressor as in the form of gas, which will be maintained at a high temperature and high pressure. In order to exchange it to a liquid, the heat must be removed from it. So, if I want to go for a chain process, I have to remove this excess temperature, or we can say that high temperature we have to remove it. So this is can be accomplished with this process is called a heat exchanging process, which is done by the condenser. So the refrigerant flows through one circuit in the condenser. In the other circuit, the cooling fluid, which is in the form of air or water at a temperature which is lower than the refrigerant, and that heat therefore transfers from the refrigerant to the cooling fluid, and as a result we can see that the refrigerant condenses to a liquid form that has been shown in the figure. So this is the evaporative condenser. This is the refrigeration where the absorption taking place. So refrigerant, we have told it, water diffusing coil, refrigerating point. This is called evaporative process. This is a chain like process where we maintain the high pressure, high temperature, then we transfer to a low temperature, low pressure. This coil will goes on circulating all these things so that all this process will be carried out in the condenser. This is a chain like process we do it. So this is the domestic refrigerator, what we use in an home appliances. Refrigerator is nowadays a refrigerator becomes one of the essential equipment in every day-to-day life. We require it. So the primary function of this refrigerator is mainly used for freezes, is to provide food storage space maintained at a low temperature for the preservation of the food. So whenever I want to preserve any food process, food content, I have to maintain a low temperature. It is essentially that we can call it as a secondary function is the form of is a formation of ice cubes or for domestic consumptions. So there will be two split ups will be there. The lower section will maintain the food preservations, which maintains a low temperature, whereas the upper part of the the refrigerator, which where we can make an ice cubes we can make it, or anything which we want to maintain a high cooling effect, I can maintain in the upper section of the refrigerator. So the storage temperature we have to maintain about 0 to 4 degree Celsius, that is to 32 to 39 Fahrenheit, is a satisfactory for preserving the food, so that the food will be very fresh. For the short-term storage of frozen foods, if you need it, however, the temperature must be below the freezing point, which is required. So this is how they have been maintained. So the evaporator is the domestic refrigerator. They form like a box which serves the freezer for storage of frozen food as well as for making any ice creams. So it is mounted above the food storage space, I told that. So the evaporator is held at a temperature of about 18 degrees Celsius. So that upper part should be maintained at about 18 degrees Celsius or 0 degree Fahrenheit. So the general storage space is cooled by the natural convention. The mechanical vapor compression cycle as well as the absorption cycle are adopted for domestic refrigerators and freezers. So what is a mechanical vapor compression system? It has an edge over the absorption system because of this compactness and more efficient of an electrical energy. So we have seen that the mechanical vapor compression systems are mainly used for saving the electrical energy.